is Newton's law of motion. Newton's law of motion was made by one of the most influential scientists, which is Sir Isaac Newton. In 1686, he presented his well-known three laws of motion. These three laws of motion describe the motion and interaction of massive bodies. The first law of motion states every object or particle will remain in a state of rest or uniform motion unless it is acted upon by a resultant external force. Mathematically, sum of F equal to 0. This means that an object or particle could not change its current motion unless there is some force acting on them from the outside. The resistance of change in the motion of massive bodies is also known as inertia. The second law of motion describes the relationship between resultant force and the change in motion. It states the resultant force acting on a particle is equal to the mass of the object multiplied with its acceleration, or the change in motion is proportional to the force. Mathematically, F equal to ma. A force will cause a change in velocity of an object, and the change depends on the mass of the object. The third law of motion states, for every force or action in nature, there is an equal and opposite reaction. Action and reaction forces act on the different objects. This law is related to two different objects, and it describes that forces always happen in pair. Mathematically, F action equal to negative F reaction. Our problem statement. Every time we drive on the road, we often see a car towing a trailer or a truck carrying a trailer, so that a lot of stuff can be moved at one time. At the same time, this vehicle also go through many different types of roads to reach their destination, such as flat roads or hilly roads. Therefore, we want to identify if the acceleration of the vehicle and the tension of the tow bar change when they go through a flat road and hilly road.
A trailer of mass 550 kg is attached to a car of mass 1000 kg. The car and the trailer are connected by a light tow bar, moving along a straight horizontal road. The engine of the car exerts a driving force of magnitude 12,500 Newton. The car and the trailer experience resistance of magnitude 1,500 Newton and 650 Newton. First, find the acceleration of the car. Second, the tension in the tow bar. First of all, we need to sketch the free diagram for the trailer and the car, which is there are four components: the resistance force, the gravity force, and normal force. And also, the car implies the same force, which is we need to consider both. For horizontal part, we are going to use the F equal to ma formula because there are acceleration in the car and the trailer. For the trailer, there are tension minus 650 equal to 558, which is we will get tension equal to 650 plus 558 equal to 1, formula 1. And next, for the car, which is the horizontal part also, we will use F equal to ma, which is there are force, engine force, resistance force, and tension equal to 1000 A, which is 12,500 Newton minus 1,500 Newton minus tension equal to 1000 A, which is we will get tension equal to 11,000 minus 1000 A, and we will put it as 2. 1 equal to 2. Why? Because tension equal to tension. So we will get 650 minus 550A equal to 11,000 minus 1000 A. And we will get A equal to 6.68 meter per second square. Next, for the tension. How to get the tension? We will substitute A equal to 6.68 meter per second square into 1, which is we will get 650 plus 550 times 6.68 equal to 4,324 Newton.
So we are moving to the next situation, which is situation 2. A car of mass 1000 kg is towing a trailer of mass 550 kg. The car and trailer are connected by a light tow bar. The car is moving up a hilly road which is inclined to the horizontal of an angle beta when tan beta equals to 0.75. The engine of the car exerts a driving force of magnitude 12,500 Newton. For the car and the trailer experience resistance to motion of magnitude 1,500 Newton and 650 Newton respectively. And the situation is like the figure shown beside. So A. Find the acceleration of the car, and B. The tension in tow car. First, we create a free body diagram for trailer, and by using its component m equals to 550 kg, we use the formula of F equals to ma, and we will form a T minus 650 Newton minus 550 G sine beta equals to 550A. And then the first equation we can form is T minus 3,887.3 equals to 550A. And then from 1, we can form the second equation, which is T equals to 550A plus 3,887.3. And then the next step is we create a free body diagram for car, and using X component, but m equals to 1000 kg, and we use the formula of F equals to me, then 12,500 Newton minus 1,500 Newton minus 1,000 G sine beta minus T equals to 1,000A. And then we can form the third equation from this. 5,114 minus T equals to 1,008. And then we substitute 2 into 3, and then it will become 5,114 minus 550A minus 3,887.3 equals to 1,000A. And then from here we can find A is equal to 0.79 meter per second. And then for the question B, we can substitute A equals to 0.79 meter per second into 2, which is T equals to 550 in bracket 0.79, which is A, plus 3,887.3. And then we can get T is equals to 4,321.8 Newton. So the final answer is the acceleration of the car is 0.79 meter per second. B. The tension in tow car is 4,321.8 Newton.
In conclusion, we found that there is a difference in car acceleration and tension in the tow bar when going through a straight horizontal road and a hilly road. The more inclined the hill, the more the acceleration of the car and the tension of the tow bar. Therefore, the acceleration of the car must be increased in order to pass the hill. Also, a tow bar that capable of carrying certain load. Finally, mechanics including Newton's law of motion can be applied in many areas in our life, such as engineering, sports, and many more.